Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 556 next greater element third. Before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes to this problem. So let's get right into it. What problem is asking that you are given a positive integer n, and what you have to do using the digits of n, we have to make a number that is smallest but greater than n. So let's take example. We have this. We are given 1234. This is our n. And using 1, 2, 3, 4 as a digit, we have to make the smallest but greater than number. A greater number, sorry, than n. A greater number than n could be, if we arrange them in decreasing order, this, but this is the greatest. We have to find something in between. So let's see. If we do this, is it the smallest but greater than n number? I would say yes. This is the number. So we have to return this 1243. This is what we have to return. I hope this much is clear. Let's see the approach or the observation that would lead to the right direction in for solving this problem or observation. First observation we have already made. What it is? Traverse from the right. As you can see in this case, when we traversed from here, if we took these two numbers and swap it, we get the smallest. But is it always true that if we swap the last two, we will get the smallest but greater than the n? Let's see. Let's take another example. Let's swap these two. As you saw over here, let's do it again. I think this is smaller than n. N is greater, but what is required? The opposite case, this should be greater. So this is not happening every time that we will swap the adjacent. So what we can do? We have to find the number which will participate in the swap. We have to find the number. So let's take this test case only. Let's see. If we swap 2, 4, let's swap it to 4, 2, 3. Is it the smallest greater number than n? It is obviously greater, but is it the smallest? The smallest number would be this. This is the smallest number. You can see this is the smallest number. This is the smallest number. Now, there are two observations in this only. So if we have a case something like this, increasing, what we do, we swap the adjacent. That's it. But there can be a case something like this, decreasing, increasing order, decreasing. When it is decreasing, this will fail. So when it stopped decreasing, this is the number. When it stopped decreasing, that number is the one that will participate in the swap. This one is for sure that it will participate in the swap, and I have also verified that swapping these two will not result in the smallest. This much is also clear. So now what other thing we have to do is find the other that will participate in the swap. That will participate in the swap. So we have found this. The best thing that we can do is use 3. Why? We need something greater than 2, but it doesn't mean that it should be greatest. Over here this is 4. Why we need something greater than 2? Because we need to want to make the smallest but greater number than n. So when we do this, if we swapped it, sorry, not 3, 2, but still we didn't reach our target. What is our target? This. Something is still missing. What it is? As you can see, it is still in decreasing order. Sorry. And we have to decrease this side because we have to make the smallest but greatest. What we can do, if we have 2 digit and we have to decrease it, make it increasing, reverse that digit, because if we have something in decreasing fashion, if we reverse it, it is the smallest. So if we do that, I just got confused. Let me write it again. We do that, 2, 4. This is the smallest. What is happening? This is the smallest, yet greater than 2, 2, 4, 3. I hope this much is clear. Now let's see how we gonna solve this. The algo or the observations, we are traversing from right. I have proved everything. I'm not gonna repeat. You can rewatch the video. Traversing from the right, increasing and decreasing case will be found in decreasing. Find the number that will participate. I hope this much is clear. And after that, reverse the number. the number. And this increasing case will be handled in the code only. There is nothing to write exclusively for increasing. We will dry run it, you will understand. So let's see the code. So this is the code, and what we are doing over here, we are converting that number to string. You can convert into the vector of int. That's what I was doing, but in discuss I saw this approach of converting into the string. It is quite better. You can do something like this. If n is greater than 0, you get the x axis, the remainder n, and you push that x, and something like that you can do. You will get the digit, but it is quite number of lines. But the intelligent approach that I am discussing, that I found and discuss, is this. So convert it into string, then getting the size, the pointer, to get that we need a pointer. This is the I. So what we are doing, we are finding that the number in front is less than the number in back. What it means, the increasing order started. That's what happened over here. The number in the front is less than the number in the back. I plus 1. And you can see here we are traversing from the back, and why we are taking -2, very trivial thing, so that we don't get the overflow. We are doing +1 over here, and we get to this line. Why we are doing this? Why? If you have a case something like this, you will never find the increasing, and your I will be less than 0. As you can see, we are traversing from the right, minus. So if that happens, just return the -1. You can see over here in this test case. Let's see. Now we have to find the first person, not person, the digit that will take part in the swap. Sorry, we already found the first person, not person, the first point. The second point that we have to find that will take part in the swap is, we traverse from the backward. J should be greater than I. Why? Because we have to find it from over here, not over here, because we want number that is greater than the n but smaller. If we disturb this, it is gonna increase only. So we have to find something from here. So we find the second point, and when we find it, we swap it and break from that loop. So that's what we are doing. So when we found the 3, what we did this. We got out. This is what we did. And after that, we did the reverse, because as you can see, if we reverse the digit, we will get the smallest. I hope this much is clear. And if we reverse, we get the smallest number that was required. And what we did, we are converting into the number. And if it is greater than the int max, we have to return -1, as it is written over here. If it doesn't fit in the 32-bit integer, and int max is the limit of 32-bit. So if it is that case, we will return -1, else we will return the nums. And as you can see, we did discuss the every line. I hope this much is clear. Let's see if it is running or not for the example test cases. Yeah, it is. Let's submit it and see. Yeah, it is submitting, and I hope this much is clear. And If you did learn something, consider subscribing to the channel and liking this video and sharing with others. In the end, you have to do what you have to do. So keep grinding. Ming, you guys are awesome. See you in the next one. Bye bye.